In this video, we are going through the Gauteng 2021 pre-mock exam. It's basically the mock exam for a prelim paper. So obviously, if you're somewhat preparing for your prelims, yeah, I do suggest that this is one of the papers that you want to go through. But anyways, without wasting any time, I mean, we're going to go through the full paper. So question number 1 is a straightforward question which is asking us to do the following. It says here, the following table shows what does it show? The following table shows the assignment marks in percentage of grade 11 D learners in North Gauteng High School. Oh, 11D, like the class number. And then it says here, you have intervals, right? So people that got between 0 and 20%, 4 people. Okay, between 20 and 40, you have 5. Between 40 and 69, going on and on and on. Okay, so the total is 41. They say it here for 1 mark, they want the model class. The model class will be the class that has the highest number of learners, which is between 60 and 80. So our model class is this one. So if you're going to get the mean, right, which is the second question here that we are being asked, for you to calculate the mean correctly, right, you have to be super duper careful, because this is also calculator work that you need to know to do. So for you to know how to do this calculator work, you are going to need to add a column for yourself, and that column is going to be the, actually no, you can actually just do all this in the calculator. You can actually just do this in the calculator. Calculate the estimated mean. So when you're going to be calculating the estimated mean, right, this is what you do. This is calculator work. So in your calculator, you are going to put in the following. So before you put in stuff in your calculator, right, you need firstly the midpoint of your intervals. So let me add a column on the left here, because we need the midpoints of each of these intervals. We need them for what we are going to do. So we're going to have here midpoints, right? Midpoints. Okay, there we go. So between 0 and 20, the midpoint is like 10. Between 20 and 40, the midpoint is like 30. The midpoint here is like 50. And then the midpoint here is like, what you call 70. The midpoint here is like 90. Now the idea is, when you're going to work out your mean, you're going to use your calculator, and you're going to use the midpoint column, and you're going to use this column here. You're going to use this column, and you're going to use this column in your calculator. And this is how you do it. In your calculator, you first need to press shift, and then after pressing shift, you need to press, actually no, you just have to press, yeah, shift and then mode, shift mode, right? Shift, you press mode. After pressing mode, you have to scroll down. After scrolling down, you have to press the third one, which says stat. After pressing stat, you have to press frequency on. Frequency, you're gonna switch it on. There we go. So once you've done this, you're gonna press the on button. Right, fine. There we go. Frequency is on. Oh yeah, you did make it go on. So the moment you press 1, it's gonna go to your refreshed screen now. So what you do from there is you press mode again. You're going to press mode, and then you're gonna press stat. You see, after choosing stat, you're going to choose what you may call var. There we go. And then after doing that, you're gonna have 2 columns, one for x, one for frequency. So you're gonna have x here, frequency here, and then you're just gonna, what are you gonna do? Yeah, you're just gonna do that. And then here in your X, right, you're going to put these midpoints, 10, 30, 50, 70, 90. 10, 30, going on and on and on. Frequency, you're going to put these numbers here, 4, 5, 9, going on and on and on. 4, 5, 9, going on and on and on. So I'm actually just do it for the vibes, 10, 30, 50, 70, 90, right? And then what you're going to do is you go up to the top again, you go to the other column, you're going to put the 4, 5, 9, 13, and then 10. Okay, and then you're going to press the on button. After putting this information, right, obviously you're going to press the on button. On. And then what are you going to do? Now you're going to press shift and then the button number 1. Shift and then button number 1, which is that on top there. Shift and then button number 1, right? And then you're going to press var. Going to press var over there. And then after pressing var in your calculator, you're going to press option number 2, which is going to give you the mean. And then you press equal to, is going to give you 59.76. And that is how we do it. This is how we do it. So the thing is, right, maybe thinking to yourself, okay, fine, but this is a 3-mark question, right? So how would they know that you did the correct thing? So fortunately, you want to keep in mind that when you're going to be working this out, right, definitely you can put in the midpoints column. And then the idea is, all that your calculator does, it takes the midpoints and then it multiplies each of these values. So for example, 10 times 4 is going to be a 40. 30 times 5 gives you 150. 50 times 9 gives you 450. 70 times 13 gives you 910. 90 times 10 gives you 900. And these numbers, they add them up and then they divide by how many learners you're dealing with. These numbers added up, you get 2,450. So then to get this number here, all they did was 2,450 divided by how many learners? 41 people. 41, which gave you this 59.76. That's how you get it. And your calculator can get you that data. But moving on. So in this situation, right? In this situation, the next one, complete the cumulative frequency table provided in the answer book. So if you're gonna complete the frequency column, the cumulative frequency table, or the column rather, let's just edit here manually, So if you're gonna complete the cumulative frequency, all they mean is you're just gonna be adding these values up one by one. You see, so 4 is the first one, so there's nothing to add. You add 5, you get 9. You add 9, you get 18. You add 13, you get 30. Goodness, you're gonna get what? It's close to 31. Yeah, I hope 31 is right. 31 looks so right though. 31 just looks so right. Plus 10, you're gonna get 41, which is this 41 down here, the total. But anyways, so that's that. See above, see table above. The next question, let's see what the next question wants us to do. It says, draw a cumulative frequency in OGIVE to represent the data on the grid. Here, these mock papers, why are they just so similar? So for your cumulative frequency curve, right? You can see here your data. You need to be careful. So obviously in terms of the scale, you're going to need to use these values here to help you with the scale for the cumulative frequency section, because you're going to have 2 sections, the test marks, and then you're gonna have the frequency, the cumulative frequency. the test marks, you're going to put them down here. So we can see they went all the way to 80 and 100, and they are going in 20s. So I mean, like, that's like, we can sort of like divide this whole thing into 5. Let's see, for every 5 we have 20. For every 5 we have another 20, and then we have another 20, then we have another 20. Wait, let's see, 3, yeah, there we go. And then we have another one here, 100. There we go. So going up, we know that we have to end up at like 40. So we may need to go up in like 5s, you see. So we can maybe say here for every, let's see, 5, 10, 15, 20, 25, 30, 30. Let's just make it 2s. 5, 10, 15, 20, 25, 30, 35, 40, 35, 40, 45. There we go. So the idea is, in terms of when you're plotting, right, you're always going to be plotting this together with this. So let us do just that. So these are more like coordinates. You see, x and y. X value is 20, y value is a 4. So let's see what that's gonna look like. X value is 20, y value is a 4. So that's like somewhere there. And then the next one you can see is going to be the next one is going to be 40 and 9. 40. 9 goes just below this thing. And then you're gonna have the next one is what? 49, right? So the next one is gonna be 60 and 18. So 60 and 18, let's see what 60 and 18 is going to be. 60 and 18, that's like somewhere there. And then what's the next one now? The next one is going to be, wait, 60 and 18, right? So the next one is going to be 80 and 31. There's 80 here, 31 is like up here. 31 is like, this is 30, right? 31 is just like up there. And then last but not least, you have 100 and 41. So you have 100 here, and then 41 is what? 41 is 41 is like somewhere up here, just here. So this, your ogive, right? You want to make sure that it is somewhat grounded. So when I say you want to make sure it's grounded, I mean you can just make sure that it follows like a curve. So let's see, in terms of the curve it's going to follow, right? You can see it's like going down here like that, you see. So you want to make it just follow that trend, you see. So it looks like it's just gonna go down like that. So yeah, this is your ogive. You're gonna get your marks. Moving on to the next question. It says use the cumulative frequency ogive to determine the interquartile range of the data. The interquartile range is Q3 minus Q1. So Q3 and Q1, you can get the positions of those first, and then you can use your cumulative frequency curve to work them out. So let's do this. Position of Q1, position of Q1 is going to be equal to 1/4 n plus 1. So when you say 1/4 and n plus 1, right, the idea is n is always going to be your total, which is 41. So here it's going to be a quarter, 41 plus 1, which is like 42. 42 times a quarter is going to give you 10.5. Yeah, so what that means is somewhere at 10.5, somewhere there, you're going to trace this to your ogive. And then after tracing it to your ogive, why does this not seem very, doesn't seem very accurate. I don't know why, but yeah, man, this is just not good at all. It's not good. It's just not good. But this is what we are getting, man. 20 and 60, da 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 da. Wait, no. I think I did something. Did I do something wrong? Position of Q1. Let's try position of Q3. Position of Q3 is going to be equal to 3 over 4. 41 plus 1. There we go. Okay, so let's see here. 3 over 4. We have to clear everything in the calculator. Shift 9 and everything. So here, I'm going to put 3 over 4. The whole thing multiplied by 1 plus that. It's like 63 divided by 2. That's like 31.5. The position here is like 31.5. So if that's just the position, right, what we know is, if we're looking at our graph, 31.5 is like somewhere there, right? So let's see here. This goes up, this goes up, this goes up. There. And then if you bring it down, well, I mean, like, seems like it is just below 80 and stuff. So yeah, this is kind of what? I don't know. It's kind of awkward because it just looks a bit weird. But what we're getting is what we're getting, you know? Like, honestly, what we're getting is what we're getting. Because what are they asking for here? They ask for the interquarter range. We use the cumulative frequency curve to determine the interquarter range of the data, the interquarter range of the data. Yeah, so here we're gonna get our Q. We got Q. This is, if you're gonna estimate this, remember in the middle here would be like 50. So in the middle there would be like 45. This is like 43 almost. So Q1, we're seeing it as like 43 according to the data over there. And then Q3 seems to be like just before 8, which is like 79. So your interquarter range, therefore interquarter range, then we go to 79 minus 43. 79 minus 43. 79 minus 43, that's like 36, roughly 36. So this is like 36. There you go. That's your interquarter range. So we're going to move on to question number 2. Question number 2. This question paper, it's a mock-up prelim paper, right? And it's exactly the same like the almost very much similar to the Limpopo mock-up prelim that I did like a few days ago. But anyways, before I carry on blabbing, right? The statistics course, the full statistics course can be found on our course website. The link to that is in the description. It's basically going to allow you to like go through the entire statistics topic in like a space of about 3 hours or so, if not less. So the idea here is for question 2 says the mathematics teacher wants to create a model by which she can predict a learner's mark. And then it says here she decided to use her 2020 results to create the model. Prelims, finals. So it looks like between prelims and finals, the marks kind of go higher, as it actually does. Then it says determine the equation of the least squares regression line. So this is always a very, 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 very common question. In your calculator, you're going to press mode. And then you're going to press stat, which is the second one. Stat. After pressing stat, you're going to press number 2 again. A plus bx. After pressing a plus bx, you're going to have what you may call two columns, one here, one there. So this is x, and then there's the frequency. Okay, and then we are going to put no. It's x and y, bro. Come on now. Come on, my bro. Nah, fam. Come on. So x and y, right? So the idea is you're gonna put your x values in this column, your y values in this column. Just like 55, 35, going on and on and on. And then 57, 50, going on and on and on. So in the calculator, all the data is inside, right? So once you have all the data in your calculator, this is what you are going to do. You're going to press the on button. After pressing the on button, you're going to press shift, and then you're going to press the number 1 button. This is if you're using the Casio calculator. See, shift 1, and then obviously you're going to press reg for least squares regression line. Reg. After pressing reg, you're going to press the mean. The mean is like no, we need A and B. So you're going to choose A, right? If you choose A in your calculator, the answer that you're getting there is the following. You're going to be getting there 12.01. If you repeat the whole process, you're getting there B is equal to 0.88. So your equation, you're going to say here, the equation of least squares regression line, it's y is equal to A plus bx. That's the standard form. But then once you have this A and B, right, you're going to say y is equal to A plus bx. There you go. Anyways, for 2.2, it says the following here. It says use the equation of the regression line to predict the final exam mark for a learner who attained 46% in the preparation exam. So in this situation, right, if you're going to predict what a person is going to get in the finals, you see that's y. They've given you x. So in our equation where x is, we're going to put the mark that they gave us there. And then whatever y value we get, that's the final mark. So this is 0.88. X is like 46%, right? Okay, let's do what we gotta do. 12.01 plus 0.088. No, it's 0.88. And then multiply by 46. This is giving us 52 point something. 52.45. 0.49. Well, the one thing is obviously these look like they have rounded off to the looks like they're in the questions here, right? These are all whole numbers. So here, if we're gonna have a whole number, we're likely to round off using the 4. So this is going to be 52%. Moving on, it says, could you use the equation to estimate the preparation mark for a learner who attained 76 in the final exam? Give a reason for your answer. So let's see. In the finals, right, people are getting different marks. And the question asked, are we able to predict the mark if someone got 76 in the final exam? Wait, could you use the equation to estimate the preparation exam mark for a learner who attained 73 in the final exam? Well, this kind of a question, we have to be careful because one way or the other, one or the other. In this kind of equation, right, remember your value for x is what determines what your final mark is going to be. So the funny thing with your least squares regression line, right, unfortunately, it's somewhat a one-way street or a one-way stream, in the sense that you can have x values, you can use them to determine y, but then your y values, you cannot necessarily use them to determine your x values, because the x values produce the y value. So in this case, you're simply going to say here no, because the x values, wait a minute, because the x values which are the preparation exam mark, which are the preparation exam marks, you see, these preparation exam marks produce the final exam mark. Final exam mark. There we go. Now the big idea here is the reason why the preparation exam marks produce the final exam mark is because your preparation exam marks, it's more like your independent variable. So an independent variable is the one that produces the outcome. So because the preparation exam mark is an independent variable. Your independent variable. Okay. So 2.4 says the following for 4 marks. Show that the point this lies on the regression line. Okay. So this point is basically the mean for the x values, the mean for the y values. So the idea is, if you're going to show that points lie on what you may call, if you're going to show that this point and this point lie on a line, you're going to have to throw them both into your equation, and your equation needs to balance out. So for you to get the average for the x and the average for the y, this is what you do. Remember, the data is still in your calculator, so you're still going to press shift, and then you're going to press stat, which is button number 1, stat. Afterwards, you're going to press shift stat 1, you're going to press reg for 5, reg. After pressing reg, you are going to press 4, which is average. There's the one for the x, there's the one for the y. So for the x, you're seeing the 60.58, and then you do the exact same thing. For the y, you're going to see the 65.33. Now in your equation, right, you're gonna need to put these points in there and show that the equation balances out. That's how you show that there are points that pass through. It's a point on the line, you see, because this is a specific point, 1 point. So doing that, you can see here the y value is 65.33. No. We have to solve for y. So y is equal to 12.01 0.88. What else is this also? X is 60.58. 60.58, yeah. 0.58. And then the following here, let's see. This in green, right? Everything in green is gonna give you 65 point. Let's see in the calculator here. Because we know it's supposed to match, that's for sure. Don't even know I'm busy just doing it. 60.58. It's giving us 63.32. So the decimal really doesn't matter. You see, therefore, so here, because we have stated that the y value is equal to the 65.32, this equation balances out. You see, so as long as our equation balances out, let's see, left hand side here, let's go to our right hand side. So because our equation balances out, we can easily then say, therefore, we know that this lies on the line. So here, therefore this lies, wait a minute, wow, did I just say lines? This point here lies on the regression line. Regression line. Regression line. Fantastic. 2.4 says we need to get the correlation coefficient. Again, free marks here. You're gonna use your calculator again. You're gonna say mode. Oh no, stat. Stat. I mean, wait, no, shift stat. No, bro, come on, shift. Yeah, shift. And then the button number 1. Looks like this. See, stat. And then you're going to press reg again. You're gonna go to R. Our R in this case is 0.98. There we go. That's the way we like it. Let's move on to question 3. So as mentioned, the stats course, you can find the link to that in the description. But basically the link in the description is going to take you to the course website. And depending on when you're watching this, right, you may find yourself lucky. Because on the course website, depending on when you're watching this, you may find yourself bumping into the all access pass for $99. You'll have access for 30 days. It's a once-off purchase, so meaning it's not like a subscription, but you will have access for a full month. If you click there, if you click on buy, there are 2 options. You see, you can see these are the FT details. The other option you can buy is by just going to the website, putting in your card details, and you'll be on your way. Moving on to question number 3. Question number 3, analytical geometry. So the big idea with analytical geometry is, I mean, as the name suggests, you're gonna need to analyze stuff. You know, so the thing is, if you don't give yourself time to analyze properly, things are not gonna go well for you. But anyways, let's see. It says in the diagram, PQR. PQR is a triangle. PQR. It has vertices. And then it says here, calculate the length of QR. So calculating the length of QR is very important. What did I just say? Very important. I mean very easy. So you're gonna have square root of this thing here. It's like x1 minus x2, y1 minus y2. And then this is the big idea. So if you look at the coordinates, right, we have Q and R basically. So Q and R, you basically have like x1 here, y1, x2 here, y2. And there's really nothing much to this question, really. It's just free marks. So you have -3 here and 5. So -3 minus 5 squared. And then you're gonna have the 3 minus 3 squared. Really? No, -3 and 3. -3 and +3. Okay. So this, you don't even have to bother yourself. Just put it in the calculator. The whole thing. But it's fine. Let's just go a step further, because why not? -8 squared. -6 squared. 8 squared. 8 times 8 is like, what? 48? No? 60 something. 64. And then this 6 times 6 is 36. So this is going to give us 100, is it? Maybe. Probably. But yeah, 100. And square root of 100 is just 10. Huh. Moving on. So the analytical geometry course, the full analytical geometry course, you can find that on the course website. The link to that is in the description. Because, for example, I just actually wanted to show you this deal. Because I don't know if, but I just showed you now. I don't know, I'm back here. If you're lucky, if you hop onto the website, you might bump into this, because this is more like a metaphor to say it can end at any time. Anyways, they say we should get the midpoint of QR. Well, getting the midpoint of QR, we may just find it at the X is there, but who knows? So with Q, we were given a certain coordinate, R we're given a certain coordinate. So let's see, Q here is -3, -3, 5 and 3. -3, -3, 5 and 3. X1, Y1, X2, Y2. The midpoint is like 3 minus -3, 5 minus -3. And then this is like 3 plus 3, which is like a 6. 5 plus 3, which is like a 8. Simplifying, it's like 3/4. That's the gradient of LR. Probably gonna need it for something. But anyways, let's see. Determine the equation of the line passing through P and M. Wait, did I just work out gradient when I needed the midpoint? Bro, come on. And I did this the other day also. Hey, that's weird. X1 plus X2, right, is what gives us the X value of the midpoint. Y1 plus Y2 is what gives us the Y value of the midpoint. So since we have Q here and R, you can just say -3 plus 5. -3 plus 5/2. That's like what? -3 plus 5. That's like 2/2, which is a 1. Kind of promising. And then here, -3 plus 3. Oh, yeah, as predicted. This is going to be at the origin. I mean, it's going to be passing the x-axis where the x values are 1, the y values are 0, which is somewhere over there. That's the midpoint. Now, this we may need it in the future. I can already foresee it. This question, again, it looks so familiar. These papers, it feels like they're just recycling and recycling. For some odd reason, these papers feel so familiar. Determine the equation of the line passing through PM. Where's PM? PM. So we need the equation of this line. Okay, that's an interesting line. There we go. So there we go. Area. What am I even saying? So that the equation of that line is not going to be too crazy, because you can just use the 2 points to get the gradient and then throw in one coordinate that the line passes through. Like, it's quite straightforward. Gradient of PM is going to be equal to y2 minus y1, x2 minus x1. So the idea here is x1, y1, x2, y2. So this is like 3 minus 0 minus 5 minus 1. So let's do it. 3 minus 0 and then minus 5 minus 1. So minus 5 here minus 1. This is like 3 divided by negative that. So this is like negative a half actually. Okay, fine. And then here they said determine the equation of the circle. No. We're not even halfway done. I'm already moving on. Bruh, come on. Let's see here. Y minus y1, x minus x1. And then this is like a negative a half. That's the gradient. That's the gradient. We need a coordinate that the line passes through, of which we can just use let's use p. P is negative 5 and 3, so that's like negative 5 and 3. So this is like y minus 3 x. Because it's a minus negative 5, you're going to put a plus 5 here. Multiplying inside your brackets, you can have negative a half x and then negative 5 over 2 there. And then obviously when the 3 goes over, you're going to be plusing it. This is going to give you negative a half x, negative 5 over 2. If we're going to plus that 3, let us see what it gives us, because this is like negative 2.5. So if you plus 3, that's going to give you a half. We love to see it. We love to see it. So let's keep moving. The next one says determine the equation of the circle which has diameter QR. So if the circle has the diameter QR, right, this is the center. So 1 and 0 is the center. That's your A and your B value. Because if this is the diameter, like we know that this is equal to this, right? So that's the radius. The radius, you can just work out the distance between M and R, or you can just get QR and cut it in half, which we have here. You see. So anyways, let's see. Equation of the circle, right? Remember, it's just x minus a squared, y minus b squared, and equal to r squared. And then, let me see. The next thing is the following. What do you mean by the following? The next thing is what now? The next thing is, okay, we know that the M is the midpoint, right? That was like 0 and 1. So that's like what? 0 and 1. That's like A and B. And then radius, we know it's radius is half of 10. So the equation, remember you always put the opposite, but for x, I mean like 0 is 0, you see. B, that's like minus 1. R, that's like what? Radius, right? The radius is like 5. Yeah. So all this being said, we're done technically. The next question says, does the point P lie inside or outside the circle in this equation? Motivate your answer. So I mean, like the one way or the other, it's all about measuring the distance from the center, because the distance from the center, right, is 5. So if from P to M it's more than 5, then it's outside. If it's less than 5, then it's inside. If it's equal to 5, then it's on the circle. So let's measure the distance PM. So the distance of PM, right, you're gonna have square root. Remember, P is minus 5 and 3. M is 0 and 1. No, 1 and 0. So this is like x1, y1, x2, y2. So the distance here is going to be like minus 5 minus 1 squared, 3 minus 0. Now, all this being said, right, let's see what we need. Negative 5 minus 1, that's like negative 6 squared. 3 squared, that's like what, 9. 6 squared, that's like 36. And then it's like 44. No, bro, it's like 45. Square root of 45 is what PM is. Of which square root of 45 is, what is square root of 45 in the calculator? Square root of 45. So it's obviously an interesting number to get, because I mean, like, square root of 45, you know, what can you say? Square root of 45 is the number 6 point something something. So you see, so square root of 45, right, is bigger than the radius, which is 5. Therefore, P is outside the circle. You see, it's all about the radius. 3.6 says the following. Determine the coordinates of S if PQRS is a parallelogram with S in the first quadrant. If S is in the first quadrant, it means that S is like, let's see, somewhere here. Yeah, this is where S is, somewhere over there. And then for you to get that point right, you need to just know, how many marks is this question? It's actually, you can just use logic for this one, because remember, these points here, these are parallel, these here, right? And you also have to remember that these are parallel also, these here. So what you can actually just do is, remember, comparing the x value of Q and the x value of R, that distance is the same as the x value of P and the x value of S. So for example, from -3 to +5, that's like 8 units difference. So from -3, if you move 8 units to the right, you're going to end up at like +3. And then when you compare the y value here, the y value of 3, the y value of -3, it means from here to go to -3, it's 6 units downwards. So meaning from here to go to there, in terms of y, it's going to be 6 units upwards. It's just going to give you a 9. You see? So if you want it written out as like some calculation of some sort, you can just even do it like that. You see, your value of S, right, the x value, all you did was, you know that you take -5 and then you add 8 going to the right, just because here from -3 to 5 you also add what you may call 8. So you see, -5 plus 8, and then the y value, we know that from this y value of 3 you have to add 6 going upwards, because from here this y value of -3, you have to go 6 upwards to get a 3. So we're going to put a 6 there. So it's like negative, what did we get again? We're starting at +3, so 6 upwards is like a 9. So let's see here, 3 plus 6, and then here, therefore, S is equal to -5 plus 8. -5 plus 8 is what now? -5 plus 8 is 3, and then 9. There we go. So with everything here being said, right, we need to calculate the size of QPR for 4 marks. So we're not done though. Oh no, we are done. We are moving on here. QPR, where's QPR? Where's QPR now? Q is here. Q, and then there's P, and there's R. So we need to calculate this angle. This one here. This is the angle we need to calculate. So us calculating this angle, right? We need to be careful, obviously, because I mean, like, how many marks is this question? It is how many marks? 4 marks. 4 mark question. So this 4 mark question, we have to think about it logically. When I say logically, I mean we just have to be careful. When I say careful, what do I mean? I just mean a lot of things, man. Well, we have that. We have like the distances of these lines, right? So we can actually use the cosine rule to get this angle, because this distance we can work it out. We have it, because from -5 here to +5 there, that's like 10. Because you see the y value there is the same as the y value there. The distance of PQ we don't have, but we can work it. Wait, do we have the distance of PQ? I feel like we have the distance of PQ. Somehow I just feel like it. But if we don't have it, doesn't matter. We can easily get it using the distance formula. The distance of QR, we have it. We got it to be a 10 also. Oh, bugger, did we? Wait, we actually did. Huh. This is an isosceles triangle. Wow. Wow. Anyways, let's get PQ, the distance of PQ, because we need it. PQ is going to be equal to x1 plus x1 minus x2 squared, y1 minus y2 squared, and then this is like what is this now? You're going to have here -5 minus -3. So let's see. -5 minus -3 squared. And then the other one, you're going to have there 3 minus -3. So it's like 3 minus -3. And then all this in the calculator. Let's see what it's got, but let's just, yeah, I guess putting it all in the calculator just saves time, you know? So in the calculator, let's see what we're getting here. We're getting -5 plus 3 squared, and then plus 3 minus -3 squared. And then what do we have? Square root of 10. No, 2 square root of 10 actually. That's the way we like it. So let's put this thing here, 2 square root of 10, right? It's the final answer. Interesting answer actually. But at the same time, I'm thinking, this feels like overkill. But it seems like it's getting us the answer. So, I mean, there are many ways to do this question. So let's just say it is what you thought of first and you're just running with it. So with with all these points, right, 2 square root of 10 here, for you to get QPR, right, you can use the cosine rule, because the cosine rule basically needs you to have all 3 sides for you to get an angle. So the cosine rule, if you're gonna get an angle, you can say the angle. In our case here, the angle we are dealing with is what? QPR, Queen's Park Rangers. QPR, right? It's gonna be equal to A squared minus B squared minus C squared, the whole thing over minus 2BC, and the whole thing you put it under a. Is this a square root symbol? No, bro. It's not a square root symbol. It's a shift cos item, because all that would have happened here is you would have isolated your angle in your cosine rule. So here, these 3 will be the 3 lengths of your triangle. And the idea is, right, when you're going to be working out an angle, these 2 sides here, the side over here, let me just make it maybe in red, the side over here and the side over there, these 2 sides, they're the ones that are on the sides of this angle, right? So what you need to do is the following. They're the ones that are going to be at the bottom, and then at the top it's all the 3 dimensions that you have. So here you have cos, shift cos, right? All the dimensions that you have. Remember, the A squared will always be the side opposite the angle that you have. So the A squared is our 10, it's going to be 10 squared, and the other 2 are these 2 sides there. So let's do it. It's gonna be 10 squared. Do this 10 squared minus another 10 squared minus 2 square root of 10. The whole thing over minus 2 and then 10 here and then 2 square root of 10. So all this in the calculator. Let's see what we're gonna get. Fingers crossed, actually. Fingers crossed. Shift cos, and then we're gonna get a fraction. 10 squared minus 10 squared minus this. I forgot to square it. 2 square root of 10 squared. So that's like interesting. 2 square root of 10 squared. What's this one now? Minus 2, 10, 2 square root of 10. Then we have close bracket. 71.57. That's good. 71.57. That's the way we like it. Okay, this is all good. We can move on to question number 4. Question number 5. Things are getting interesting. We have a Euclidean geometry question. No, trigonometry, bro. Come on. So obviously the trigonometry course, right? If you want to go through the full trigonometry syllabus or the full trigonometry topic from start to finish, you can just click the link in the description. It's going to take you to the website, of which on the website, depending on when you're seeing this, you may be just lucky because there's currently a sale for the all access pass, 30 days access, just $99. You can either make a purchase on the website directly, or you can just use the EFT details. So the big idea is these are online courses. You're able to go through the content at your own pace, at your own time, you see. So this is, for example, the trigonometry course. You see there's 5 different chapters. You have multiple lessons, and all the lessons are properly detailed, giving an idea of what you need to know for each of these maths topics. But anyways, carrying on with this question. It says here, simplify the following without the use of a calculator. You see, oh, no, come on, my guy. No, this is actually one of the chapters. You see here, we need to draw a diagram, right? Now, this falls under chapter number, if I'm not mistaken, chapter 3. If you look at the title of chapter 3, it says solving trig expressions using diagrams and sketches. That's chapter 3. That's what this is telling us. Like, that's what this question is actually asking. So this question says cos 25 is equal to square root of 1 minus k squared. So it's fine. We can just draw a right angle triangle here. Right angle triangle. Cos 25 is adjacent over hypotenuse. So the idea is, because there's nothing down here, you can put it over 1. Then you can put this as your hypotenuse. The other thing you always need to try and do is to get all the angles of your triangle and get all the sides. So the angles is easy because here, it's going to be 90 minus 25. The angle here, you can see it is just going to be 65. Yeah. And then the value here, you can just label it what? Y. But if you're going to solve for y, you can use Pythagoras, because 1 squared, which is the hypotenuse, is going to be equal to y squared plus square root of 1 minus k squared. And then you square it here. And then you're going to have square root cancels the 2 there. And then you're going to have, we're solving for y, remember. So this is like plus 1 minus k squared. This is like a 1 squared here. So what we now know is that the 1 minus k squared goes to the far left. So here 1 minus 1, it goes away. The k comes over, it's k squared. Square root both sides, you're going to have k is equal to y. So this part here is, we're just going to label it k. We have just proven it. Okay. our question is now easy to work out. So sine 25 is like opposite over hypotenuse. Opposite over hypotenuse. Sine 50, this is double. Yo, this paper looks very similar to what I did just not so long ago, the Limpopo one. Like, wow, man, like, what a wow. So this should remind you of double angles, right? Because remember the double angle of sine is going to be equal to 2 sine theta and then cos theta. Now the big idea is this, you can also expand it like this. You see 2 sine 25 cos 25. And then, oh yeah, we have each of these. Sine 25 is like 1 over, I mean, k, it's just k. And then cos 25 is just, that whole thing there. It's like square root of 1 minus k squared over 1, like that. This you can put it over 1 also. What? Yeah. I don't even know I'm doing this fraction thing because it's not necessary. Like, bro, what are you doing? This is just the answer. This is the final answer. And this looks weird now because it doesn't look like a bracket. This is our answer. Yeah. Crazy, weird, but that's the one. And you keep it moving. So in the light of all we have just been doing, right? Yeah, let's keep going, man. Let's keep going. Let's keep it moving. So with the next one, simplify the following without the use of a calculator. We don't need a calculator, but out of 7, it's gonna be lit. So you usually want to work with small numbers, you want to make them as small as possible. So I mean, like, you also want to just double check what they're close to. This is close to 90 years, but it doesn't seem like making this a 20 is a good idea, but it may just be because this looks like it's gonna have a 20 some way somehow. So yeah, let's maybe do that, but it's not gonna turn into a what you call. It's not going to turn into a course, because if you're gonna want to write this as 90 plus 20, I mean, you could, but it's not necessary to change from sine to cos if you see it's not really gonna make a difference. But what I'm trying to say is don't overthink it either. So here I'm just going to choose to change this to 180 plus 180 minus 70, because this is also going to have some 70 somewhere. But let's take it slow. Sine 180. I may just end up, I will just see it's a 7-mark question. So don't be too quick to, disregard certain things. 60 is already a special angle, so you really don't have to do much. You don't have to do anything yet. This, what I always say is, if your numbers are bigger than 360, remove 360 from there. Remove the highest multiple of 360. That's going to give you 180, which is good. So this is like cos 180. Cos 180. And then 10 to 50, right, is like 180 plus 70. Yeah, 180 plus 70. And then 360, this is going to be 360 plus 20. 360 plus 20. Okay, there we go. Now all this being done, right? 180 minus, so you can just use the cast diagram actually. CAST. So 180 minus is in this quadrant, where sine is a positive, so it's going to be sine 70. And then this 1060. We might as well change to numbers already. No, not yet. I like to just change the numbers usually at the end. So let's just leave this as cos 180 for now. 180 plus is in this quadrant where 10 is a positive, so we can put 1070 there. And then here 360 plus 20, that's like 360 degrees plus, that's a positive, so sine 20 over here. We may end up getting 20 some way somehow. Well, this is a 7-mark question, so best believe we're not going to stop anytime soon. We have to keep going. So now I think we can deal with numbers now. Or not yet, the 70s and the 20s. Let's see what we can do there. So it seems like this, we cannot avoid the whole 10. Actually, no, we could just change. Because what? Because look, this is going to be interesting. Sine 70, right? Times 1060. The big idea is, firstly, I mean, let's deal with cos 180. Cos 180, right? If you have a cos graph, it looks like this. What you know is that at cos 180, this is going to be a -1. But no, let's just leave it for now. We're not yet changing stuff to numbers. What I want to do is, I want to write out, okay, let me not rush. Let me take my time because I want to show you something. Let me show you something. Yeah, why did I just think of that? Okay, so this sine 20, right? You can change it to sine 90 minus 70. So if we change it to 90 minus 70, you can then eventually change this to like a cos, you see? Because if you look nicely here, 90 minus 70, so it's like 90 minus 70, you're back in the first quadrant where everything is a positive. So, yeah, sine 70 here. Don't mind me writing too many steps. I'm just trying to not leave anything out. So this thing here, we know it's going to tend to cos 70. I want to write it here deliberately because there's something I just want to show you in the next step. Because, yeah, this question is nearly done. So fortunately here, what you want to recognize is that the sine 70 and the cos 70 here, this becomes a tan 70. But you can write it at the numerator. Tan 70, tan 60, cos 180, tan 70. So that now this cancels this. Tan 60, now you can do numbers. Because remember, in your 30-60 triangle, this is what you have. 30, 60, 1, 2, square root of 3. So 1060 is like what? Opposite over adjacent. Opposite over adjacent. So this is like square root of 3. At the bottom here, this is like -1. So here, therefore, negative square root of 3 is your answer. We did is get it. It was is nice. Now we move on. Excuse me. Gotta stay hydrated. So this question, the former question, but it looks like the kind you don't want to overthink at all because it looks like the difference of two squares. Yeah. Is it the difference of two squares? Yes, it is. The reason it is this is just swapped around, you see. So if you look at it nicely, 1 minus this, right? And then 1 plus that. So you see here, 1 plus, if you swap these around, right? 1 plus square root of 2 sine 2.5. If you do this, the idea is, you see, 1 times 1. I mean, whichever way, this is the difference of two squares. So it means 1 here with a negative. Oh, no. The difference of two squares, it means you have to square this value, right? And then you have to square this value also. And you put it in brackets with a minus in the middle. So 1 squared is just that. And then this value squared, you see, is going to be square root of 2 squared, which is a 2. And then sine 22.5 squared, which is sine 22.5 squared. That's the difference of two squares. So this is what you're dealing with. Fortunately, 1 squared is just 1, you see. So we have 1 minus 2. I don't know, I'm writing it as a separate step, but I just want to make it clear that, you know, we are supposed to just think outside the box. The main question here is still just, we are supposed to simplify the following without using a calculator. Now this should remind you of the double angle of cos, because I mean cos 2 alpha, this is equal to 1 minus 2 sine squared alpha. Now this is where we see alpha, right? We basically have the 22.5. So this is like cos 2 and then 22.5. Now this, so what we now know is what we have over here, right? This whole thing here, we know it's just this thing here. And what that means is, you see, we can now just work with the, which one is easy to work with? Because we're supposed to just simplify the following without using a calculator, show all calculations. Well, it looks like what we're working on, or what we're working with, right? It's gonna go as far as cos 45, and cos 45 is equal to 1 over square root of 2. That's the way. We like it. So that is that. Let's move on. Proving this thing here for 5 marks. Okay, it is not so bad. The reason why it's not so bad is because it also seems like it has some difference of 2 squares shenanigans going on here. Because look, this is like, this has a plus in the middle, this is a minus, this is a minus, this is a plus. So yeah, where there's fire, where there's smoke, there's fire. Because yeah, it just looks like it, eh? So in this kind of a setup, I mean, for you to avoid just doing things randomly, right? I suggest you just do the basic stuff. Like, for example, these are 2 fractions, right? Or you're supposed to prove the identity. Yeah, it's fine. These are just 2 fractions. So what you can do is, because it's 2 fractions and you're subtracting, you can just get the LCD first and, you know, do a bunch of stuff. You'll see things will work out. So let's see here, LCD. The LCD, clearly it's going to be this thing times that thing. So it's going to be cos x minus sine x. And then cos x plus sine x. Now, what you can do is, you see here, this thing here, you're going to multiply by cos x minus sine x over cos x minus sine x. That's what you're going to multiply this thing by. And this thing here, you're going to multiply it by cos x plus sine x over cos x plus sine x. So this is the same as like multiplying by 1. So what's going to happen is, you see the top, you have this that looks exactly like that. So they're identical, you see. So you can have cos x plus sine x. This whole thing is just squared. And then here, this times that, you're also just going to have cos x minus sine x. The whole thing is just squared. The bottom part, though, you're going to have these 2 pasted together. Fortunately, this is just the difference of 2 squares. So when you multiply them together, cos times cos is like cos squared x. I mean, it's just the difference of 2 squares, because you have this and this that look identical, this and this that look identical. In the middle, you have a plus and a minus. So this thing here is just cos squared x minus sine squared x. If you multiply out these brackets of your LCD, you'll end up with what we have just written down here. So looking at how we're supposed to turn this into something that looks like the right-hand side, it looks as though multiplying out these brackets is unavoidable. So we just have to do it. So here, cos plus sine x squared is going to be cos squared x, and then plus 2 sine x cos x, and then plus sine squared x. If you multiply out this bracket, if you multiply it by itself. And then for this one, yeah, you have to be careful. You have to put brackets, because here you're going to have cos squared x minus 2 sine x cos x, and then plus sine x. That's the way I like it. So it's like this, gets smaller. What do we have? This is like minus 2 sine x cos x. And then at the end we had plus sine squared x. So what do we do now? We have the bottom part here, the bottom part over there. So this is like cos squared x, sine squared x. Yeah, we have to multiply inside the bracket. So you can see the 5 marks is coming from you're just writing out a bunch of stuff really, because hey, there's really nothing much going on here. We're just writing it out, being patient. And I think we can all just low-key see where this is always going. Things are just gonna cancel each other out. If you multiply inside, you're gonna have minus cos squared x plus 2 sine x cos x, and then minus sine squared x. Oopsie. Yeah, I'm running out of space because, yeah, you think you're clever. Let me just see. Highball. Huh? Hey, not getting bigger. Wow, it's stuck. Okay, but I think we can all see what's going on here though. We wrote the sign over here. The last sign, the sine squared x. The whole thing is over this bottom part. This is the double angle of cos. So we can just actually write it as cos 2x like that. Now stuff might at least cancel, because you see here there's minus in the plus, minus in the plus there. These are like terms, so 2 sine x cos x plus 2 sine x cos x, that's like 4 sine x cos x. But then what we see at the top there, it's resembling the double angle of sine. You see the 4 here is just the issue. So we can take out a 2, then we have 2 sine x cos x. And then we're home free because now the top, we can change it to sine 2x. The bottom, we can change it to cos 2x. There we go. Oh, wait. Sine x, sine 2x over cos 2x. That is going to be a 10 2x. There we go. And then you can say, therefore, left-hand side equals to right-hand side. Whoa. There we go. You see? So don't be scared to do a lot of writing, because all that writing is what's going to get you your marks. You cannot get your marks if you do not do the writing. The writing is unavoidable. 5.4 says we need to determine the general solution. Okay, determining the general solution, I mean, like here we need to be able to spot compound angles here, because like cos, sine, I mean, like it's a no-brainer. So as long as they're, usually if you start with, you have to do the cos's first. Yeah, because normally with the double angle of cos, right, the compound angles of cos, it's like cos a plus b, right? This is equal to, why am I writing so big, bro? This is how I'm running out of space here. How this guy easy writing, like, never mind. So make this smaller. Yeah, so it's like cos a, right, plus b. This is equal to cos a cos b. If this is a plus, this will be a minus, and then sine a. So here we're gonna have cos theta. No, sine theta. Sine theta is equal to negative square root of 3 over 2. So now what? Okay, so we said here, you see a and b, it means that this is a, this is b. It represents a, it represents b. So you're gonna say cos, you see, we're trying to simplify first before you can even do that. So here, 3 theta over 2 plus theta is what we should have here. Now you want to see this as 3 over 2 theta. Now that's technically what it is. So let's just write it like that, so that you can see that these are just like terms. 3 over 2 theta is what you're dealing with. So this is like 3 over 2 plus 1. You see, these are like terms. So you're going to have your cos 3 over 2 plus 1. That's like 5 over 2 theta. And then this is equal to negative square root of 3 over 2. Negative square root of 3 over 2. So with all this being said, right? We need to be careful. We need to be careful. We need to be very, very careful. The reason why we need to be careful is because we just need to be careful. Anyways, let's move on. Let's see. So if you're going to get the general solution, here you need to get a reference angle first. So you getting a reference angle, we know that you always need to make use of your number the way it is. Oh, no, I made a mistake. If it's a plus here, it's a minus there. So if it's a plus here, if it's a plus here, it's a minus there. So if it's a plus here, it means it's a minus in here. Oh, snap. Almost made a mistake, bro. There we go. Yeah, because it was the opposite. So when you're gonna get your reference angle, right, you need to do shift cos. You need to say shift your reference angle. Gonna be equal to shift cos, and then you always take this value as a positive value. You take it, then you take the number as it is because you're getting a reference angle. So this value in your calculator, shift cos square root of 3 over 2 is like 30. And this is like 30 over here. So with all this being said, right, this is what we need. Since you now have your reference angle, you're going to take the cast diagram here, CAST. Now in this cast diagram, you need to work out where cos is a negative. Cos is a negative here and there. So it's the quadrant 180 minus the reference angle and the quadrant 180 plus the reference angle. So let's deal with those two quadrants one by one. We need to deal with them nicely. So, hey, out of space already. How was you? How? Really, bro? Second quadrant, you're gonna say this here is equal to 180 minus the reference angle plus K360. Here's the element of integers. And then you're gonna have here 180 minus 30 is like 50? No, 150, right? Yeah, 150. 150 plus K360. You know, the alarm is ring. 180 plus 1 plus K360, right? And you're gonna say K is the element of integers. But you see, you're not done here because you see here you're gonna divide by a half everywhere. So you're dividing by a half everywhere. You have to get 300 here plus K720. K is the element of integers. This is like theta. What a wow. I don't know why I gave myself so little space for this question because it's like, bro, come on. We literally have no space, bro. Come on. Hi. Let's maybe move the cast diagram. Maybe we might have a chance. The cast diagram really can just go up there or something. And then the rest of this thing, let's just move it, you know. Yo. Let's move this thing here. Let's move it to the far left. So that here we can work with the other quadrant, which is the 180 plus quadrant. So let's put it maybe in like a color that will stand out, like the green, yes. So on the other side of the page, you're gonna do the third quadrant. It's gonna be half theta is gonna be equal to 180 plus your reference angle plus K 360, k is the element of integers. Okay, so with all this being done, right? What do we know now? We're gonna divide by a half here, divide by a half here. This cancels each other, which is gonna be like this cancels that. Okay, this is like theta. 180 divided by a half is like 360. Is it? Yeah, Brody, bro. Gonna be 360, bro. 360? No ways. No. It's 360 plus the 60. Oh yeah, of course. And then you have plus because remember the half actually goes for everything, including the K360 thing. So this is gonna be plus K1 plus K720. Plus K720. And then here theta is equal to 420 plus K720. There we go. This is all good. We love to see it. So this is what we know we should do, right? So moving on to the next question. Oh, we forgot to put the k as the element of integers, but k element of integers. So given this expression is equal to -1, we need to write down the maximum and the minimum value of cos b. So there's a 2-mark question. Wow. Okay, so the idea is you have to think logically here, because you have to think of like two graphs. Think of like f of x is equal to sine theta, right? Oh, no. You have to say f theta is equal to sine theta, right? The sketch here, we know it's just a standard sine graph. Goes up, down, like that, between 1 and 1, between 1 and -1, 0, 360, 180. Fine. This is your graph. The other one will, let's just say g of beta. This one, if it's cos beta, right, it's just going to look like this, gonna go up, down, and everything. So it's gonna be 1 day, -1 down here. Now the idea is this is also from 0 to 360. So if they're asking write down the maximum and the minimum value of cos b, well, the funny thing is this kind of a setup almost as the only way you're going to overcomplicate it is to think that the maximum and the minimum value of cos b has anything to do with this given expression. We might even have a 5. We don't even have a 5.2. The maximum and the minimum value of cos b has nothing to do with this. It has nothing to do with that. So we just have to think of this. You see, so max value equals 1, minimum equals -1, and there you go. And that's the way we like it. If you need to go through, more in detail tutorials or more in detail lessons on trigonometry, you can just click the link in the description to go to the trigonometry course. Now, obviously, depending on when it is that you are going through this, you may just be lucky, because as it stands on the website, right, the all access pass is currently on sale. The until tomorrow part literally just means it can end anytime, you see. So once I purchase, giving you access for 30 days, it's just 99 bucks. You can either make a purchase on the website, or you can just pay by EFT. It's 100% up to you. And remember, this is like pre-recorded material, right? Meaning you're able to go through these lessons at your own pace, at your own time. And you surely make sure that you are ready for your prelims, your finals, your junior exams, all the tests that you're basically going to be writing throughout the year. This is what you will practically need. You see, there are different lessons here in Euclidean geometry, and all those lessons are based on the work that you know you need to learn from your syllabus. It says in the diagram below, it says the diagram below shows the graphs of f of x and the graph of g of x. So f of x is a coarse graph, and excusez-moi, excusez-moi, excusez-moi. Excuse me. Anyways, so it says here we have a coarse graph and a sine graph in the interval from 0 to positive 180. And what else? Yeah, this looks quite interesting. Apart from it looking interesting, it just looks a bit odd. Yeah, it just looks a bit strange actually. But anyways, we'll see. And then it says here, I think it just maybe looks like it's not to scale, because I'm like, if this is 1 and like, yeah, it just looks a bit weird, this thing. But it says here the graphs of f and g intersect at p. Where is p? They intersect at p and q. So I think this is p and this is q. And then it says here m is 90 coordinate 2, which is like up there. It is the turning point of g. And then you have n here, right, which is 180 coordinate 1 at the end of the graph. And then it says here, yo, shouldn't be yawning so much. It says we should get A, B, C, and D for 4 marks. So you getting A, B, C, and D, it's it's all going to come from you being able to interpret your sketch. So to start off, right, firstly, let's do, so with the coarse graph, right, the idea with the coarse graph is that we can see that it's going to go all the way down to like -1, and it looks like the highest point that it goes to is +1. You see, from 1 to -1. So remember your amplitude, if you think of the equation of an amplitude, it's the maximum y value minus the minimum x value, the whole thing over 2. So the maximum y value is a 1, the minimum y value is a -1. This is going to be 2 over 2, which is a 1. And then with all this being said, right, with all this being said, you need to keep in mind the fact that the amplitude of the coarse graph is a 1. So it means that A is a 1. See, A is equal to 1. B is the frequency of the coarse graph. Now, the frequency of the coarse graph basically tells us how many graphs in a space of 360 that you get. So, excuse me. With your coarse graph, you can see that in a space of 180, you have half a graph. So another 180 degrees, you're going to have another graph. So meaning in a space of 360, you have 2 graphs. Yo, excuse me. You seem to be yawning too much. I'm sorry. But you can actually use a formula, because B is frequency, right? Because frequency is equal to 360 divided by the period. Now the period is how long it takes to get a full graph. So in our case, your frequency is the variable B. So you're gonna have B here, frequency. Now the big idea is that what you may call your period is how long it takes to get a full graph, right? So your period here is 180. So you can see here it's like 360 divided by 180, which is just a 2. Now with the others, right? Let's see here. C is the amplitude of the sine graph. The sine graph, you can see also, like, it doesn't look like it's been moved up or down, you see. So it's gonna go all the way up here to 2, come back down, and it's gonna go all the way to that -2. So the amplitude here is gonna be a 2. So C is 2. D is the frequency also. How many graphs you see in a space of 360? Wait, what? What? D is kind of odd. D is weird. Yeah. No, it's not actually. This is like half a sine graph because 180 degrees you have like one bell shape, and then another 180 degrees you'd have had another one like here. So in a space of 360 here you just have one graph. You see, because in a space of 360 you just have one graph, because 180 degrees you only have half a sine graph, because a standard sine graph looks something like this. You see, there's 0 there, there's 180 in the middle, there's 360 at the end. So that's what we're saying we're dealing with. So let us keep it moving. Let's keep it moving, man. Let's keep it moving. So excuse me, carrying on, right? We have 6.2. It says if this coordinate, if these are the coordinates of Q, write down the coordinates of P for 2 marks. Well, these points would need to be symmetrical to a certain extent. So if this is like 158 and 0 point something, so it's like 158 here, right? 158 point drink some water. Yo. This is 158 point what? 158.56, right? That's what you get here. And then this is like 0.73. 0.73. Like that. Now the big idea is the following. Yo. My throat. Come on, my throat. Work with me now. So what you need to keep in mind is the value of P and the value of Q, they will have the same Y value. So this is also going to be 0.73. To get the X value, we just have to be a bit creative. When I say we have to be a bit creative, what I mean is, we already have the equation of the graph, so we can just sub in the coordinate, the Y value, into the graph of any of our equations, you see. So remember, so we have here, we can say g of x is equal to 2 sine x, like that. So what we know is the Y value is 0.73, right? So this is like 2 sine x. Solving for x, we're going to divide both sides by 2. Just like divide by 2, divide by 2. And then 0.73, right? 0.73, say 0.73 divided by 2. That is like 0.365. 0.365. And then this is like sine x. And then we have to do shift sine. Shift sine 0.365 equal to x. Shift sine, and the answer, that's like 21.4. I'm getting 41. So therefore, this is your value of, this is your coordinate of P. And yeah, it's just a 2-mark question, so we don't have to struggle too much. I don't know why I wrote up there when I could have just written down here. Zoop. Anyways, the other one is a 1-mark question, right? It says the following. If x is between 0 and 180, determine the values of x for which the distance between the y values is at 3. So you see, this is saying the y values of g minus the y values of f, where is it going to be at 3? So if you look nicely, like, it's going to be at 90, because you see the distance here is like, the distance down here is like 1, going up there is like 2. So 2 plus 1 is a 3. So that's going to be happening where x is equal to 90. That's why they made it a 1-mark question. And then the last one. You're kidding me. I didn't give myself space for this. Doesn't make any sense. Come on, man. Oh, come on, Brody, bro. Hey, let's finish this question then. So for 2 marks, right? Let's see what they're asking us to do here. They're asking us to work out where f of x multiplied by g of x. They're asking us to work out where this is going to be smaller than, what is this? Where is this? They're asking where is this expression going to be smaller than 0? So if you're going to answer questions like these, you need to do it strategically. When I say you need to do it strategically, I mean you don't just do it presumptuously. You actually have to have a method. So here's what I mean. Firstly, all this is saying is you are dealing with y values of f, right? Multiplied by y values of g. So the big idea here is if you multiply these two, they're asking where will you get a value that is smaller or equal to 0? Where will you get a value that is smaller or equal to 0? Now, the only way this left side of your equation can be smaller than 0 is if either this one is a minus times while this one is a plus, or where this one is a plus while this one is a negative. To make better sense of that, if you look at the sketch, right? If you look at the sketch, the sign graph is always positive. So let's just say everything in red here, these are positive y values. Oh no. Everything in red, you see, these are all positive y values. That's everything in red. And then, all this being said, if you look at your course graph, the part that's in red here, you see, those are the positive y values. This part in red here, positive y values. The part that I'm going to put in blue here, these are negative y values. So our task is we want to look for the x values, because remember question 6 here we're basically just well, here we're technically working out for x. You see, we're solving for x. So the x values where you have, we want x values where you have your one graph having positive y values while the other one having negative, and then your one graph having negative y values while the other one having positive y values. That's what we're looking out for. So in our sketch, we can easily see that that's happening in these specific places here. So the one place where that's happening is, for example, here. It's happening from this point here, which we need to get, up until this point here, which we need to get. That's the only slot where you have positive y values for the one graph while having negative for the other one. So for us to get this point here, this is just the x-intercept of the graph of f. So we're going to make f equal to 0 to find those x-intercepts because we need them. Let me might as well use this space here. F of x, where is it equal to 0? So f of x is going to be equal to, the amplitude was like a 1. So it was like cos. And the frequency was a what? Was it a 2? Yeah, my bro. So this is cos 2x, right? Solving for x here. You should make f of x equal to 0. Let's see what you get. So shift cos 0 equal to 2x. We're going to actually do some general solution shandies here, actually. Yeah, something like that. Something like that. Because you see here, shift cos 0 is what? That's your reference angle. Shift cos 0 is like 90 degrees. 90 degrees? Okay, fine. So the reference angle is 90 degrees. And then we're working with where, if you use a 0, you just use where it's positive. So in the first quadrant, it's going to be, you're going to take it as it is. 90 is equal to, no, 2x is equal to 90. 2x, 90, and then divide by 2. Divide by 2, x is equal to 45. And then what? Yeah, so here you remember the second quad where cos is also positive in the fourth quadrant, which is like 360 degrees. But that one is too far. It's not going to work out. So what you do is here you can put your plus k 360. K is an element of integers, right? And then here, when you divide by 2, you'll also have plus k 180. Now, what you then do here is, you see this k 180, you can throw in a specific integer to try and get other places in your equation where your graph is equal to 0. So you see the first one you're getting is this. They're telling us this is 45. So this, you're going to get it from just making k equal to 1, you see. Let k equal to 1. So you're going to have x is equal to 45. So you're going to have like 45 here, right? Plus 1 times 180, which is like what? 225. That's what you're going to get for x. You got that for x, right? So meaning this is like 225. So now you can answer your question. The graphs will have, separate y values from 45 to 225. So let's say here, come on, let's see. This, we're going to say x is bigger. Wait, let's see. This is asking where is it smaller or equal to 0? Yeah. So we're going to have to say smaller or equal to, probably bigger or equal to 45. And then smaller or equal to 225. 225. There we go. 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 Okay, so let's move on to the next one. Because I did this was 3.6.3.2. Let's move on to question number 7. So obviously, if you need more questions like these, right? I mean, like also functions and all that, you can always hop onto the course website. Because remember, on the course website, fun enough, if you're lucky and depending on when you're watching this, right? The big idea is the all access pass is like a bundle that includes all the topics that you need to learn for your grade 12 maths. So this bundle obviously is going to be giving you 30 days access to everything on the website for just this fee. And remember, this basically means that this bundle includes like all your different topics, so you don't even have to worry about leaving anything. And this is like material that's already there, and it just means you're able to work at your own pace. You're able to finish the syllabus at your own pace. And if you have any questions, you can always just hit me up. You scroll down to the bottom, you see there's like WhatsApp over there. There's Instagram there, TikTok, Instagram page again. So you'll always be able to like hit me up whichever way you can. Question 7, we have arrived. So having to have arrived, let's see. It says in the diagram, P, Q, and R are 3 points in the horizontal plane. So it's P, Q, R. These are down here, you see. Now they said here, same points. These are points in the same horizontal plane. Then it says here, these are equal, right? PR is equal to QR, which are both equal to M. And then this angle here is equal to X. This one. This angle there is equal to X. And then they say there, SP is perpendicular to PQ. So it's like this here. This is a 90-degree angle. Now, that being a 90-degree angle, it says the angle of elevation of S from Q is Y. So it's like this angle here. That's Y. Okay, so I guess we're just reading the sketch. Now it says for 5 marks, express the area PQR in terms of X and M. Well, getting the area in terms of X and M, that doesn't sound so bad, but for 5 marks, though, we have to be careful. Fortunately, they told us that one side is equal to M, so this side is automatically equal to M. Now, the other thing is, if this is equal to x, this side is automatically equal to x because angles opposite equal sides. So what you want to state first is, remember, this is not analytical. I mean, this is not Euclidean geometry. So depending on what you say, you don't necessarily need like a statement and a reason. But if you find yourself like putting a statement and a reason, that's 100% fine, because I mean, like, you need it for Euclidean geometry anyways, you see. So here we're gonna jump straight to saying that, okay, since we want an area, remember your area rule says something like a half times A times B times sine the angle. This is the area rule. So with this being the area rule, right? This area rule is just like the cosine. The reasons for you to use the area rule, right? It's just the same as the cosine rule, meaning you need to have like a triangle, and that triangle basically needs to have an angle given in like the middle somewhere there, and then two sides there. As long as you have something like this, you're good, which is what we're going for here, because at least we know this is M, this is M, and we're gonna state nicely that this middle part here is just 180 minus 2x, you see. So let's do it. Let us do it, people. Let us do it. So let's see. Oh, so much space. Ha ha ha. So I wrote down the area rule. Fine. It's just generic. Now the way this is laid out, right? Let's see. This is going to be equal to a half. A is like M again. Yeah, I think I overreacted with this one. Gave myself way too much space. Way too much space. So this is gonna give me it's gonna give me a half squared, a half M squared actually. So this is like a half M squared, half M squared sine. This is like 180 degrees minus, so that's like sine 2x. And what is this now? Area. There we go. There we go. There we go. There we go. So with all this being done, I mean, you'd be wondering, but where are the 5 marks gonna come from? The 5 marks are going to come from wherever. Well, one way or the other, right? Yeah, you know what? Let's just put the statements and the reasons. It's really not gonna like hurt. Forget hurt. It's just going to, I don't know, man. Let's just do it. I think even though it's not Euclidean geometry or whatever, I mean, like, it's still maths. You know, you might as well just do it so that you don't like get marked down unnecessarily. You see, so Q1 is equal to X. The reason is angles opposite equal sides, and then the angle R, right? R is going to be equal to 180 minus 2x. The reason is interior angles of a triangle, man. Interior angles of a triangle. Okay, fine. Statement, reason, so that we can say all that we have said down here. 7.2 says, show that PQ is equal to 2m cos x. For 4 marks. PQ, where's PQ? PM. PM. No, they said PQ. Yeah, PQ, 2m cos whatever. So we need to get an expression for PQ basically. So that is not going to be too much of a problem because we have the cosine rule anyway. You see 180 degrees here minus 2x. So it's like we're literally home free because we just have everything we already need. So let's see. I think, what did I do? So it's like this is the cosine rule at a squared plus b squared plus c squared. No, bro, come on. In the middle there's an equal to sign. Equal to sign. And the other thing is, you see, this is like minus 2b cos a. Now, this is what we need to do. So we just need to know that these ones here are the ones that go together. The pair will always be in this way. This angle is opposite to this side. If you can put it like that in your calculations, you'll always be fine. So for example, this angle is R, this side is PQ, you see. So this here we're gonna say PQ squared is equal to the other two sides squared. So it's like PR and QR. PR squared plus QR squared minus 2 multiplied by PR and also, what is this? QR. So there's QR here. So there's QR over there. And then you're gonna close this bracket here. And then this is like cos, the angle is R, remember? So yeah, there's angle R. So with everything being written out here, we need to just drop in the numbers now. You see, PQ is what we're looking for. PR, where we don't have specifically numbers, we just have like variables. So it's M and M, you see? M squared. Uh-oh, I feel like I took the long drive, but you know, as long as it's working out, let's see what we're getting. M times M, remember, and then cos 180 minus 2x. So already these are like terms, 2m squared minus 2m squared. 180 minus 2x. 180 minus is in the quadrant where sign is a positive only. So this would change, and then here you would have cos 2x. Here you can take out a common factor, which is 2m squared 1 plus cos 2x. Then if you're gonna square root both sides, right, this will have a square root, and this will not have a square because you would have, you know, removed it. But the other thing is, I mean, like the way this is looking, it don't look good, man. It don't look good at all. Like I feel like I botched it. I feel like I botched it good because, you know, it's just not coming together, you know, it's just not coming together. It's just so annoying. Hey. Well, whichever way, this may still be fine, but why did the question even ask? Oh, we should show that it is what it is. So yeah, like this, it seems like it's not doing. So you'll just have to leave the cosine rule. Try something else. Maybe the sine rule. Probably the sine rule works because normally, I mean, like with this kind of information given, the sine rule is usually just going to work. So let us try it out. Let us try out sine rule. But you will be thinking, but why did we do that whole thing if we're gonna not go through with it? Well, whichever way, you know. I mean, we didn't. I just wrote what I knew would work, but in this case, it's not 100%. It's not matching the image that they gave us, so we might as well just try again. In the sense that you see, fortunately, this is a right angle triangle. If you were to use the sine rule, you can, because you have what is this? You have you have one side and one side. You have here one side and another side. So if you want the length of PQ, so you can start off by, since you're looking for a length, right? You can put PQ on top. Its opposite angle is 180 minus 2x. So because we're gonna put 180 minus 2x here. 180 minus 2x, and then equal to what? Equal to the other side is like x and m, right? So it's like, let's do QR, because that's the, but QR has a length already. QR is like m, so let's do m on top. At the bottom here we have what do we have at the bottom? At the bottom we have QR, the angle is going to be x. It's like sine x, because that's how the sine rule works. So Here you want PQ, so you can cross multiply. Oh yeah, you don't have to cross multiply. You just have to multiply this thing here so that it goes away. 180 minus 2x. And then this thing here cancels this thing here. You're gonna have PQ on its own equal to M. Wait, what? What you do on one side, you have to do on the other side, obviously. So it's like times sine 180 minus 2x. Okay, so what now? We have to be careful now. So what we do is it's M times sine 180 minus 2x sine x. Okay, we are literally where are we now? So with the way this is set up, right, you obviously have to be a bit creative, but not too much, because I mean, like, we're practically done. This is like what? I'm writing in blank. M times 180 minus sine is a positive there, so this is like sine x. But where's the cos gonna come from now? Oh no, sine 2x, bro, come on. Yeah, this makes better sense because the top part is a double angle. 2 sine x cos x. And then at the bottom is like sine x. And then obviously the one big idea is that you're going to have to cancel this and this. And then you have m 2 cos x. Well, if you want to write the trend m's not around the way exactly they did, just like what they have here, you're 100% welcome. Cos x. 2 marks. Hence prove that SP is 2 m cos x 10y. For just 2 marks. Wow. So okay, what you can actually just concentrate on is getting the length of SP, like maybe. So like you have your, what is this? They're asking if you could measure. Are we being asked to measure? Yeah, probably are. But it says we should prove that SP is 2 cos 10y. So I think I can find something like that at the top up here. Wait a minute, what is going on? Did I just blank out? Like, seriously, bro? Come on. Yeah, so where are we? Yeah, so you just want to look for SP. So SP is this distance. I was literally just drowning in my own thoughts, not even saying the correct thing. It's this line here. So if you get the equation of that line, that's not too bad because of PQ. So PQ, what did we get for PQ? PQ. Hi. PQ, let's leave it. So if you're gonna get this length of this, wait, but we did we? I think we did get PQ. Why does this feel so familiar? There it is, man. There is PQ. So it's 2 m cos x. So 2 m cos x, 2 m cos x for this distance. So we have an angle on the side, angle on the side. Perfect. So this is enough room for us to carry on with what we need, because looking at what we have been asked, right, we can just use normal trigonometry to work out SP. So for some odd reason I read SR. But anyways, let's see what the right angle triangle can help us with. Wait, what do you think again? Right angle triangle. Yeah, we have a right angle triangle here. And then we have the angle that they gave us there is whatever angle is there, but it's yeah, let's just carry on with this triangle. So far we know that this is like y, and then we're looking for SP, right? And you're probably 2m cos x. Let's see if we can put that. 2m cos x. 2m cos x. So why am I putting Whoa, bro, are you serious? 2m cos hmm, cos x, yeah. So that's gonna go here, right? So if you're gonna get SP, you can just use normal trigonometry. Adjacent, opposite over adjacent. So you can use 10y. It's got the opposite, which is SP. Adjacent, which is this item here, 2m cos x. So the only thing is, you see here, they have SP as the subject of the formula. So you can just multiply by SP. Just multiply by SP. So yeah, let us do that, please. And then, so yeah, what's going to happen here is, you see, we're multiplying by what we did on one side, we have to do on the other side. So there you're going to say therefore. You can even start with writing SP now. Therefore, my criminal record is like, wait, hold on. SP is like TY 10y dot 2m cos x. Yeah, so this is what you then get. It is all good. It is all good. Let us move on. So remember, for more tutorials like this, you can just check out the link in the description so that you go to the online courses. Now, depending on when you're seeing this, I do think that you're probably a bit lucky, because if you look at what's on the website, right, the all access pass is currently on sale. It was a sale for 99 something. It's currently on sale, you see, meaning you'll have access to 17 courses. Remember, everything is already on the website, so you will be able to work at your own pace, start at your own pace, finish whenever you want to finish. It's really not an issue. Question number 8. It says so. Complete the following theorems. The angle in the semicircle is equal to 90 degrees. That's not difficult. The opposite angle of a cyclic quadrilateral is the opposite angle of a cyclic quadrilateral is equal to the this one is kind of awkward, because it's like they want us to refer to the theorem that states that opposite angles of a cyclic quadrilateral are supplementary. The opposite angle of a cyclic quadrilateral, okay, is supplementary. Let's just say supplementary is supplementary to its opposite. The opposite angle of a cyclic quadrilateral is supplementary. Hey, I'll just leave supplementary for now. Yeah, when I say it's supplementary, it just means that its opposite counterpart will make sure that they both add up to 180 degrees. So let's not overthink it. It says O is the center of the circle in the diagram. Okay. And then it says here, BP is produced to M such that OM is perpendicular to AB. We have a 90-degree angle there. Okay, perfect. So with this 90-degree angle, what do we now know? It says here, AP intersects OM at L. Where's AP? AP, there's AP here, right? It intersects OM at L, yes. And then it says the following. It says BS is a tangent, B going all the way to S. This is a tangent, right? So if this is 35, it means that this angle here is also equal to 35 because of the 10-chord theorem. Now, the other idea is this is a radius side and this is a tangent. So it means that this is automatically equal to 90 degrees. So if this is 90 and O1 is equal to 90, because they gave it to us as a 90-degree angle. They said they said AB is perpendicular to OM. So if this is 90 and this is 90, it means that we're dealing with lines that are parallel here. So all these conclusions here, you need to keep in mind that they're going to help you as you will be working out questions that they can ask. So they say this is 35. Fine. So they say calculate with reasons the size of A1. So A1 is this small angle over there. Oh, no. I made a mistake. No, man. A1 is the one that's 35 because of the 10 chord theorem. Excuse me. I'd made a big boo-boo. So the reason why it's only A1 is because the triangle that is inside the circle is this one only. So yeah, but I did is anyways, yeah, so this angle here is the one that is equal to that one because of the 10 chord theorem. I didn't even see this was out, but we're here now. So this is equal to 35. The reason for that, you're just going to say 10 chord theorem. You see, 10 chord theorem. 10 chord theorem. So with the 10 chord theorem, we have just got A1. So the next one here is O3, right? So O3 is, let's see what O3 is. O3 is this line, is this angle over here. Now remember, this one is going to be double the 35 because the angle at the center is double the angle at the circumference if they are subtended by the same chord. You see? So here we have the same chord here. So this same chord is subtending A1. So that's why this is 70. So we're just going to tell them that this is equal to O3. Yeah, O3 is equal to double A1. A1, which is going to make it 70 degrees. The reason is angle at center of circle. See? So, all that being said, we can move on nicely because it wants us to get P3. So any shape that has actual dimensions given should always be easy. P3 is also going to be easy because you see here you're working with red eye. I mean, lines that are equal to each other. So if this is 70, this is going to be 180 minus 70 divided by 2 because they are equal to each other. You see? Angles opposite equal sides. But let's tell them that OP is equal to OB, red eye. I mean, that's blunt, right? OP is equal to what? OB, right? The reason is red eye. So that now we can say P3, therefore P3, right, is going to be equal to OBP. OBP. The reason is angles opposite equal sides, like that. It's just angles opposite equal sides. So now that we have stated that those two angles are equal to each other, we can easily say therefore P3 is equal to 180 minus that 70-degree angle. Whatever is left, you cut it in half. And then the reason for doing this is interior angles of a triangle. So you see here, this is going to be 110 divided by 2, which is like 55 degrees. That's P3. And all this information is very needful because actually you could have also just said, what you call this is 55 because that would have been another route where you say this is tangent perpendicular radius, you say this is 90, you remove the 35 from 90, and then you'll be good. Let's see what's the next thing. They want us to get M1. Yeah, these are obviously the easier questions, asking us to get M1 here. M1 is not difficult because you see here, we know that O1 is equal to 90 degrees. It means the other side is also equal to 90 degrees. So if the other side is a 90-degree angle, let me just do this. This angle here is also a 90-degree angle, right? So this triangle here that we see is a right angle triangle. And this right angle triangle, that's where M1 is, you see. There's 55, there's 90 here, the whole thing, right? So you can easily get M1. So let's tell them that BOM is equal to 90 degrees. BOM is equal to 90 degrees. The reason is angles on a straight line. Angles on a straight line. And then now we can easily then say M1, more of a conclusion also, therefore M1 is equal to 180 minus the 90-degree angle minus the 55. Whatever is going to be left here is, I think, 35. Is it 35? Coincidentally. 35. What do you mean by 35, though? Come on, it's not 35. Can't be 35. Oh, it is actually. Yeah. Oh, alternating angles also. But yeah, whichever way, everything is just linking up. But it's okay. So this is going to be 35. The reason for writing all this was interior angles of a triangle. But everything we stated in the beginning, you see, everything links up. It has to link up. So anyways, the next question, they're asking us to prove that OLPD. Where is OLPD? LAPD. OLP. Where is D now? I think they meant B. But there's no D there. OLPB. Let me check again. Is there a D? Let's see. There's A, B. There's not even a C, bruh. Yeah, I think they meant OLPB because there's no D in this question. So if you're gonna prove that this shape here is a cyclic quadrilateral, this one, this shape, this one is the one that you have to prove is a cyclic quadrilateral. This one. Now you can do that by showing that an exterior angle of a cyclic. No. Easiest one is the what you may call opposite angles of a cyclic quadrilateral supplementary. You see, and you can use angle P2 and P3. You see, this is a 90-degree angle. So this is 90 and this is 90. So they're supplementary. So you have a cyclic quadrilateral. So let's tell them that we know that BPA is 90 because it's an angle in a semicircle because it's subtended by the diameter of a circle there. So let's tell them BPA is got to 90 degrees. The reason there is angle in semicircle. Angle in semicircle. There we go. And then now we can say BPA plus what? What's that angle there? BPA plus BOM. That's BOM, right? BOM. If you add this up, they should give you 180 degrees. You see, so here you can say therefore OLPB is a cyclic quad because opposite angles are supplementary. Okay, and then now we can do the next one. They want us to prove that BS is parallel to OM. You see, very simple. Now it's a 2-mark question only. So we already stated that this is 35 and we know this is 35. So we can just use that. You see, SBM is equal to M1. No, we can just say SBM is equal to 35. That's a given. M1 is equal to 35. That's proven. So because they're both equal to 35, we can say therefore BS is BS. BS is parallel to OM. The reason is alternating angles are equal. See, alternating angles. Angles. Come on, angles. Want angles? Alternating angles are equal. Okay, so they C now. C says we should prove that. Well, it's still in the name of proving that. We should prove that OP is a tangent to the circle L. We should prove that OP is a tangent to the circle through PLM. Where is PLM? There is PL and M. We should show that OP is a tangent. So the line we should show as a tangent is this line over here. I don't know which color to use because everything now is just like a rainbow, man. It's just like a rainbow. So we should prove that OP is a tangent to a circle that passes through these points here. You see PLM. Now the idea with what we have here is the fact that this is a tangent. You see. Now this tangent here, if this was a tangent, then it means that this angle would be equal to that one. You see. So we might as well use the colors that we were using for the 35 originally, because that's where all this is going, you know. Then I just have to prove that this is equal to this angle. Because if we do that, we'll be fine because of the 10 cot theorem. So proving that that angle is equal to 35 is easy, because you see the whole thing there is 90. It's already been proven. We know it. This is 55. It's also been proven. So we can just restate those statements. You see, P3 is equal to 90 degrees. Is it P3? I feel like I'm messing up. No, it's BPA. The angle BPA. Yeah. BPA equal to 90 degrees. This has been proven already. And we want to tell them that this angle here is 55. P3 is what I should have just carried on, but anyways, we're gonna rewrite it here. P3 is equal to 55. This has also been proven. And then as a conclusion, right, we can now state that the angle P2, you see, therefore P2, it's more of a conclusion. Therefore P2 is gonna be equal to 90 minus 55, gonna be left with 35. So because you've shown that this angle definitely is a 35 also, you're good to go, because you are showing that this angle at the tangent is equal to the angle here, which is subtended by this chord, right, of our circle that would have gone around there. So in this kind of a situation, you can then just say, therefore, this will be a tangent to the circle. So you can say, therefore, OP is a tangent to the circle through P, L, and M because of the converse of the 10 cot theorem. Because of the converse of the 10 chord theorem. Yeah, but we'll have to see it. Let's move on to question number 9. Question number 9, what do we have here? Question number 9 looks pretty interesting. It says, in the diagram, right, DE is a tangent. Okay, yes, we have a tangent here, so it's a tangent to the circle at E. Perfect. And then what does it say now? It says DFG. So there's like DFG here. DFG here is a straight line, right? And I mean, like, according to the sketch, these are equal. Okay, interesting. And then they told us that yeah, DE is equal to EF, fine. And then they told us that what? Oh, it's also equal to FG. Where is FG? FG is equal to DE, which is also equal to EF. Where is EF? Oh, there's no line there, but the statement told us that DE is equal to EF and it is equal to FG. That's interesting. That's very interesting. But anyways, it says here, what does it say there? It says the following. It is further given that DF, okay, where is DF? DF is this line. DF over DE is equal to Y. So what we can interpret it as is, if they tell you that DF, right, DF over DE is equal to Y over 1. If they do that, you see, if they do that, then, I mean, they're giving us maybe a ratio that we can work with, which is good, I guess. And then the next thing they said is let DEF equal to X. So DEF equal to X. This looks super crazy familiar as well. Like, Man, so much recycling of questions. Oh well, we'll have to see it, I guess. So the 3-mark question says give 3 other reasons equal to x. Give with reasons 3 other angles equal to x. Well, I mean, like, this is a tangent and this is a chord, so this is also equal to x. You see, tan-chord theorem. Because you see, there's a chord here, so the angle subtended by this chord is the one equal to the one at the tangent. So let's tell them that G is equal to DEF, which is technically equal to x. The reason is tan-chord theorem. We love to see it. We love to see it. Okay, so the idea is once you find something equal to x, you see, you trace it. So here, this x is going to be equal to this x because they are angles opposite equal sides, you see. So here, angle G is equal to FE2. The reason is angles opposite equal sides. Great. Now you can even look for an angle equal to this one, but if you don't find it, I guess it shouldn't be too bad. But the other thing is, if you think creatively, right? Remember, you have this exterior angle here. This exterior angle over here. This is an exterior angle, right, of this triangle here. So if you're looking at this triangle, right, the one angle there is equal to x, the other angle there is also equal to x. So this one is technically 2x. Now, if this is 2x, this is also going to be equal to 2x because they are angles opposite equal sides. But I'm wondering to myself, why did they mention that that is equal to x? Well, oh, the other that's equal to x is blunt. It's this one. Alternating angles. You probably saw it earlier. So I just said, to catch up. This is equal to x because these are alternating angles. So E1 is equal to F2 alternating angles. E1 equal to F2 alternating. Whoa. Bro, come on. Alternating angles. Alternating angles. So the next one says we should prove. Are we proving? Well, 9.2.1 EH is equal to EH over HY is equal to Y. So I'm assuming I have to prove. That's the only thing that makes sense here. EH over HY. Where is EH? EH. Oh, EH over HG. Okay, the other one we had was DE. No, DF. Right, DF over DE. But that doesn't really mean a lot. We should actually just use this question to help us, or the statement, because firstly, this is a how many mark question? It's just a 3-mark question because there's no heavy lifting. Remember, they told us that was it DF or DE? Yeah, they told us that DF over DE, right? DF over DE is equal to Y. This they told us. However, if you look at the lines that they're talking about, right? DF and DE, they don't really help us to show that this over this is a Y also. What can help us is the fact that DF over FG is equal to EH over HG because of the proportionality theorem. So let's actually just do it. DF over FG, right, is equal to EH over HG. So the reason for that is just proportionality theorem. So let's write that down. DF, is it DF or D? Yeah, DF. DF over FG is equal to EH over HG. This is a fact. The reason is just going to say here proportionality theorem, prop theorem. So this being said, what we need to tell them, right, is the fact that FG is equal to DE. You see, FG is equal to DE. That's a given. You see, FG equal to DE. They gave it to us. So as long as FG is equal to DE, we can say therefore DF over DE, because replacing this with DE, right, since they're equal, is equal to AH over HG. So here, therefore, AH over HG is equal to Y, because DF over DE is also equal to Y. This is something they gave us. You see, we could even, if you said, we can even just drop here given. It's a given statement. And then from there, we were able to do all we did here and show that this is also equal to Y for 3 easy marks. The next thing is, let's see what we're going to do next. Spice up the colors a bit. Orange, orania. So they want us to show that D is equal to 72 for just for a 4-mark question. Well, the crazy thing with this kind of a question is that we don't have any dimensions, but they want us to show that D is equal to 72. If D is 72, right, it means that X would be equal to 36 some way, somehow. Because remember, we have shown that D is just equal to double of whatever X is. We showed it, you see. Exterior angle of a triangle is equal to the sum of the opposite interior angles. So if this is 2x, this is 2x. Actually, we can show that this is 2x because of exterior angle of a cyclic quadrilateral. And then we can say all these angles add up to 180, right? And then we solve for x. And then we'll be good to go with the angle D. So let's start with F1. F1, we're going to say it's equal to E2 plus G. That's what we're going to say. Let's tell them that F1 is equal to E plus G. Is it E1? Which E? It's E2. E2 plus G, right? Then here you're going to say exterior angle of a cyclic quad. I mean, exterior angle of a triangle. Exterior angle of a triangle. So with this exterior angle of this triangle, right, we need to keep in mind the following. E2 plus G. What do we get there? It's going to be F1 equal to E2, right, is X. This is also equal to X. This is 2X. That's what we have gotten for F1. Then we're going to tell them that F1 is also equal to D because they are angles opposite equal sides. F1 is equal to D, so it means it's also equal to 2x. The reason is angles opposite equal sides. So here now we can say therefore 180. I mean, here we don't even have to say therefore. We could actually just say therefore because I'm like, it's more of like what we're carrying on. So here we can say D plus E1 plus F1. D plus F1 plus E1. This is equal to 180. The reason is interior angles of a triangle. And if you put the dimensions for each of these, it's like what? D is 2x. This is also equal to 2x. This is equal to x. And then if you solve for x, there's like 5x here equal to 180. What? Yeah. And then divide by 5 is going to give you 36. Well, what am I doing? X is 36. And then here, therefore, D is equal to 2 times 36. You see? 36. And then you're going to have here 72. They'll give you a whopping, how many marks? 4. If they had made it 5 at least, but oh well, we got our answer, so we really don't have to cry too much. And then they want us to prove similarity between triangles for 3 marks. DGE. We need to prove that it is similar to DEF. DGE, DEF. D, G, E, and D, E, F. Awkward. Not gonna work. See that again. DGE. There is D here. There is G here. Oh yeah, it is gonna work because this is X and X, so that makes 2X. And then there's this angle 2X, and then the single X for the big one. For the small one, there's a single X, double X, double X. Oh yeah, that's super simple. That's like super simple because we're talking about this small triangle here. We're talking about the big one, and the way we have laid it out, that's why it's a 3-mark question, because there's really not a lot of heavy lifting here. Because with proving similarity, you just have to prove that all 3 angles are equal to each other. So firstly, we can just state, if you're going to prove that these are similar, right, we can say that G is equal to, wait, what? The G here, right, is equal to the E1. That's been proven a long time ago. This has been proven. Now we can say that, what you may call, we need to tell them that, well, I mean, like this angle is equal to 2. This D is a common angle there, so that's fine. Wait, D is a common angle. Yeah, they both have D. See, the big triangle, the small one, they both have D there. So I'm kind of interesting. Oh yeah, so here D is equal to D, common angle. So you've shown that two pairs of angles are equal, right? So the third pair you can say it's equal because of the interior angles of a triangle. So we used E, we used D. Now we can just say F1 is equal to the whole of angle E. F1 is equal to the whole of angle E. So we can just say interior angles of a triangle. So here we can say, therefore, these are similar. Triangle D, GE, similar to triangle DEF. The reason is angle. Great. So this is good. We move on now. We keep moving forward because why not? So here with this being said, we need to prove that DE squared is equal to DF times DG. This one is not a difficult task because as long as you have proven that your triangles are similar, you are always able to write out specific statements. So as long as your triangles are similar, right, you know that the following is true. DG over DE, so we have DG here over DE is equal to GE over EF. GE over EF, and then this is equal to DE over DF. Fine. The reason here is just proportionality theorem. Now with these statements, right, we have to choose two of them that at least have these dimensions, lines. So there's DG somewhere. There's DG here. We need something with DE. These two both have DE, so that's our, yeah. These are the two we're gonna pick. So here we can say DG over DE. Come on now. Is equal to DE over DF, and then we're gonna cross multiply. DE times DE gonna give you DE squared. DG times DF gonna give you DF dot DG, like they want us to do here. You see, that's why this is just a 2-mark question, because I mean, like, you're literally just doing something that is just basic and straightforward. So let's move on to the next one. They want us to prove that y squared plus y is equal to 1 for 5 marks. Wow. What a wow. So yeah, this question doesn't look like it's playing games, but well, the only thing that we have that has y in it is the fact that DE, what they gave us was actually swapped around. It was DF on top and then DE at the bottom. That's what I just noticed now. You see, there's DF and DE. So this is just swapped around. You see, so what we know is, remember, DF over DE is the one that's equal to a y. So this is 1 y over 1. So if you flip this over and you have something like this, which is what we have there, right? This is going to be 1 over y. Okay. I think this kind of makes our lives a bit easier because we have 1 over y here, we have y over there, and we have our statement here. So let's see. This one here is 1 over y, right? This is dg over de. dg over de. Now, we want to involve y in an expression like this one. Let's look at dg and de. So dg is a combination of two sides. Okay. dg is a combination of two lines. So let's see there. So dg is a combination of two lines. Okay, that is helpful. de is equal to fg. So I think if we have FG in the statement with DE, we may get somewhere. So let's see here. This we can write the top part here as like DF plus FG, DF plus FG, the whole thing over DE, right? There's DE over here. But the thing is, you have to remember that if two things are both under the same, if two things are both over the same, what you call denominator, it means that the denominator can go for each of them individually. DF over DE plus FG over DE, of which what we know is DF over DE. This is a Y. FG over DE. What is FG over DE? There's FG here over DE, but then DE is the same as FG. FG and DE are equal to each other, you see. So what you know is that if you do your math properly, remember, FG is equal to DE. That's a given. Therefore, it means that Y plus, this is the same. So this is just going to be a 1, you see, equal to 1 over Y. Now, because you want to end up with Y squared plus Y equal to 1, you can just take the ones with Y to one side. This is going to be Y minus 1 over Y here equal to negative 1. Okay, let's do this. Since we have a fraction on one side, right? Let's have a fraction on both sides. Here, you can just cross multiply. So you're going to have 1 times 1 is a 1. Y times this thing here is going to be Y, and then 1 plus Y plus 1. And then obviously, Y multiply inside, you're going to have Y squared. Y multiply again, you're going to have Y. This is equal to 1. And then here, you're going to say, you're done. That's it. You don't have to do anything else. You are home free. You see, you're home free. Nothing major, nothing crazy. This is a dope paper. Now, the big idea is if you obviously know that you need to go through the math syllabus, all the courses on our website, it's going to take you a total of 24 hours to go through absolutely every single thing in terms of your math syllabus. It's going to take you a total of 24 hours. Now, what that means is if you go through like 1 hour daily, it's going to take you 24 days to finish. 24 days is just about 3 weeks to go through the entire syllabus properly. Now, if you're lucky, I mean, like, depending on where you will see this, when you will see this, the all access pass is currently on sale. This is a metaphor to say it can end at any time. And you see, you can either pay directly on the website or via EFT. These are the courses, you see. Each individual course goes through the syllabus in detail. For example, the Euclidean Geometry course, there's like 4 chapters and a bunch of lessons here that will be getting you ready for your exam. So if you need anything, you can just scroll down to the bottom of the page. You can click here to reach out via WhatsApp. You can click here to reach out via YouTube. Click here to reach out via TikTok. This is the main YouTube channel, and then here this is the Instagram math page. You can click any of these here to, you know, make contact, reach out, and all that good stuff. From my side, I will catch you in the next paper. But for now, that is that from my side. Don't forget to subscribe. Don't forget to plug your friends, because why not? You know, why not? Be the plug.